In this video we're going to look at solving some simple equations involving sine, cos and tan. So to start off with, I've just got the graphs of y equals sine x and y equals cos x between 0 and 180 degrees here. Now if you've watched the previous video you'll know that these graphs can really be extended outside of these ranges as well, so it would continue, sine would continue like this and would continue like this, and it would repeat periodically, cos would come back up here, and it would repeat on forever in each direction. But we're going to look at problems where we're just solving these sorts of equations for values of x between 0 and 180 degrees here. To make sure we're in degrees, I'll just put a degrees sign there. So let's look at the first one then. We've got cos x equals 0.6. So what I'm saying is which x value gives us a y value of 0.6 on this graph. And thankfully we can get an exact answer easily with a calculator here, so I could just we can just say that x equals arc cos, or I'm going to use the calculator notation cos inverse, sometimes called arc cos, of 0.6, and then it's just a question of plugging this into the calculator. So make sure we're in degrees mode as with other trig questions, and I'll just do shift cos to get the cos inverse function up, and then type in 0.6. and that will give me the angle there, 53.1 degrees. Similarly, if I wanted to solve cos x equals minus 0.4, I would do x equals cos inverse of minus 0.4 and put that into the calculator. Shift cos minus 0.4, and that gives us 113.6 degrees. Just doing these to one decimal place. Again, that seems sensible with the graph here. That's a value where cos is minus 0.4. It's going to be somewhere between 90 and 180, and that's what we've got here. Now I've got an equivalent problem here, but instead of cos we've got sine. It's a little bit more complicated for sine in this range between 0 and 180 degrees, because, well, we start off as we did before, and we just say that x is sine inverse of 0.4, and then we'll plug that into the calculator. So we'll do shift sine 0.4, and that gives us 23.6 degrees to one decimal place. And if we look at the graph, that's fine. 23.6 degrees could be about 0.4, that looks right. But in this range between 0 and 180 degrees, that's not the only value that has sine of x equals 0.4, because if there's that position there, which is 23.6 degrees, where it's 0.4, well actually if we go all the way over here as well, there's going to be another one just here which has also got a sine ratio 0.4. Now because of the symmetry in this graph, this 23.6 degrees is going to be the same distance here from 0 as this point is going to be from 180 degrees. So actually we've got this answer here, or a second possible answer, which is 180 minus 23.6 degrees, and that will give us the other value there on the graph. So that's 156.4 degrees, and that corresponds to this point on the graph here. So when we're solving a problem for sine in that range, there would be two possible answers, and actually for cosine in different ranges there would be as well. Just happens that between 0 and 180 degrees there's only one answer for each value, but if we went between 90 and 270 degrees it would be the same thing for cosine as well. But we're just sticking to 0 to 180 degrees for now, so it's just sine here that causes that problem when we've got two different values. Of course if we had sine x equals 1, then it would just have one value here of 90 degrees. There's no other one there, but for all the other values we're going to get two possibilities for the answer there. And of course if we had sine x equals a negative value, there wouldn't be any possible answers, because there's no value of x for which sine is negative in that range, although of course there is if you look outside the range. Finally, let's look at problems with tan x then. So this is the graph of tan x between 0 and 180 degrees. It's got this asymptote at 90 degrees where it's undefined, and it goes as high as you like. It will go up to plus infinity, so it gets enormous values just below 90 degrees here, and really tiny values, enormous large values I mean, the large negative values just above 90 degrees here. So can really get as large as you like. So let's have a look at the two different cases for tan. So tan x is 0.8. Say, well, again, I can just do x equals tan inverse of 0.8. Grab the calculator, shift tan for tan inverse 0.8, and that gives us 38.7 degrees. And that's fine. Look at the graph. Well, yeah, could easily be like that here, 38.7 degrees, and we're saying that that's about 0.8. Remember, tan isn't bounded between -1 and 1 like this one, so I could have said tan x equals 3 or tan x equals 7. There's no limit to the value here, but that's fine. So let's just have a look then. This one, what about tan x equals -2? So I'm looking for a value now where tan is -2, so I'm expecting something in this region here between 90 and 180 degrees. So let's go put that in the calculator, shift tan of -2, and it's given us something a bit strange. It's given us -63.4 degrees. So actually what the calculator does when you put in tan inverse, it gives you a value that's somewhere between -180 degrees off the left of the screen here, between -90 degrees off the left of the screen here and +90 degrees in that range here, where so it looks a bit like that. Now this graph just cycles exactly every 180 degrees, so if you want the one that's actually over here rather than this one, this distance here is going to be 180 degrees. So what I need to do with the answer I've got in my calculator here of -63 is to add on 180 degrees, and that will give me the value that I'm looking for between 90 and 180 degrees. So that's here 116.6 degrees. So you just got to be a little bit more careful there. The calculator will give you what we call the principal value of the inverse for each of these functions, and you do just need to think a little bit about the graph in each case to make sure that you're doing the right thing. So for tan, to make sure that you add on 180 degrees. For cosine here in this particular range, it's nice and simple. The calculator just gives you the answer, and for sine, to make sure that you get both of the two different values that could be the answer.